today's topic, uniform motion. We'll start with the definition. Definition of uniform motion. Motion with a constant speed and direction. Constant speed meaning you cannot speed up or slow down. Constant direction meaning you cannot change your direction, no going around corners. Three variables describe an object that's traveling in uniform motion. First, distance. We use the symbol d, small d, for distance. There will also be, in some cases, displacement, which looks like that. Okay? Second, time. For how long will you be traveling? What time? And thirdly, speed or velocity. Speed, we use a small v, and velocity, a small v with a little vector symbol above it like that. Okay? Three variables: distance, time, and speed or velocity. Okay? Next, there is an equation that relates those three variables. That equation is simply v is equal to d over t. This indicates that the speed or velocity, and the way I've written it here is speed, is equal to the distance divided by the time. Now, that creates a rate, meaning how much distance traveled in this amount of time. We refer to things that are compared against time like that as rates. Speed is the rate at which you are moving, how fast, if you will. Okay, now, this equation can be written two ways. Really, this way is speed, and if I were to write the equation for velocity, then it would look like this. Which really says velocity is equal to displacement over time, right? Where displacement and velocity are the vector quantities. And this one, speed is equal to distance over time, where distance and speed are scalar quantities. Okay, now, units. Distance and displacement units are going to be measured in meters. Time, when you substitute time, should be measured in seconds. And therefore, the velocity or speed is going to be meters divided by seconds. Meters per second. Okay, that's the unit for speed or velocity, meters per second. All right? Okay, so here's a typical question you get involving uniform motion. Question reads as follows. Mr. Physics is able to run 1.3 kilometers at a speed of 2.31 meters per second. What time does it need to complete the motion? Now we identify this as a uniform motion question because there is a speed given here and no mention in the question of an acceleration or deceleration. Okay? So, after I've identified that it is in fact a uniform motion question, I'll next select an equation. And the equation I'm going to select is, there it is. Velocity or speed is equal to distance over time. In this case, speed. Okay, what information have we been given in the question? First, here, 1.3 kilometers. Typically, I'd write that down, but I drew myself a little picture. 1.3 kilometers, well, when I substitute that in for distance, I'm going to want it in the standard units, which would be meters. So 1.3 kilometers, that'd be equal to 1,300 meters. I'll put that in for distance. 1,300 meters. For my velocity, it's given here, 2.31 meters per second. I'll put that in for my velocity. It's already in the standard units of meters per second, and if we're substituting values in standard units, you needn't show them in the equation. We'll assume any value substituted without units shown is in standard units. Find the time. Okay, basic math skills now. We'll rearrange the equation for time. 1300 divided by 2.31, we will pull out your ever useful calculator. 2.31, whoops, 1300 divided by 2.31 equals, and I get 562.770, blah, blah, blah. My answer, I'm going to round to 3 sig figs because there's 3 on the top, 3 on the bottom, round to the least number, 3. So rounding to 3 sig figs, I get 563 seconds. If I substitute my numbers in standard units, I will get an answer in standard units.